Okay, welcome to another session of Business Mathematics, Ugbs 202. Today we'll look into decision making and the uncertainty, where in other words we'll just refer to it as probabilities. Well, most of the times businesses make certain decisions under some uncertainties. Now, for instance, you can say that you may make an investment today not knowing perfectly how the market would occur or how events will turn out, and so you'll be expecting some profits tomorrow. Probably we also look at issues that, let's say, planning for demand for subsequent years, giving some information. Now, you do know that, well, in real life situations, we will not make the decisions in total darkness, or let's say you make the decisions without any information, but as to how perfect that information is to help you make the decision. So, well, we were going to kind of go through some basic ideas and decision making and these uncertainties. Well, but let's do a little recap on some basic properties of probabilities, because we are going to need them for this session. Okay, so we're going to understand what probabilities are. We say that it gives a measure of uncertainty. That's basically what probabilities are. How likely an event is supposed to occur. What is the likelihood of this occurring? Now, and so lots of us will have some certain ways of determining the likelihood of some events occurring. Now, for instance, typically in Africa, when you find the clouds gathering, well, it is easy to say that it will rain pretty soon. How about on days that the sun is so high up in the sky and someone says that, well, it is going to rain today? Now, sometimes you think about it, you do not understand, but maybe it's just been some observations over some time period. But the likelihood of that occurring, given the case of where you find the clouds gathered, would vary. Now, if you find the clouds gathered and the clouds are so dark, you can say there's a very high probability of the rain about falling. Now, if you find the sun so high up in the sky, very scorchy, and someone says it's also going to rain pretty soon, there is a likelihood. But in that case, you could probably say that the likelihood is quite slim. Now, so we're going to understand all these things using some concepts of probabilities. Now, under probabilities, normally we do what we call some statistical experiments. Now, we say a statistical experiment can be described as any situation specifically set up or occurring naturally. All statistical experiments have three things in common, which we would want to look at. Now, the experiment can have more than one possible outcomes. Now, so we will look at what that means. Now, each possible outcome can be specified in advance. Now, how about think about it this way? Now, more experiments, if you do some experiments, you can have more than one outcome. If you're going to play a football match, what are the possible outcomes? It is possible that the match will end up being a draw, or it could be a win, or it could be a lose, depending on which side you're on, right? If I want to toss a die, let me say a coin, that will be it. Now, it is possible I could get a head or a tail. Those are more than one outcome, right? But now, we can specify each of those outcomes in advance, but we cannot tell exactly which of them would actually occur with certainty. And so we give, I give these examples here. Now, an outcome of an event depends on the chance, right? And so, for instance, if I toss a coin, a head could occur, or a head could pop up, or a tail could pop up. Now, because in that case, each of them have equal chances of occurring, we'll say it's a 50-50 chance, right? 0.5. So that's what we mean by outcomes of an event depends on chance, right? And so the higher the chance, the higher the likelihood of it occurring. The lower the chance, the lower the chance of the likelihood of it occurring. But chance is chance. Even if it's as slim as possible, it's still some opportunity. Okay, now it says that after the experiment is performed, only one of the possible outcomes will occur, irrespective of the prior possibilities or chances. Okay, so like I was giving the example of the case of a football match, after the game, there is only going to be one possible outcome. It is either that one team has won, or one team has lost, or it's a draw. You can never have both teams winning in the game, right? Or both teams drawing, or both teams losing, right? It is always just one possible this thing. Or if I toss a coin, there's no way that both the head and then the tail would occur at the same time. It is always going to be one occurring. Okay, now an outcome of an experiment is the specification of all the possible distinct results. Okay, that is outcomes of the experiment when it is performed. So, like I said, now for instance, if I take a die and I want to toss a die, there are 6 possible outcomes. It could be 1, it could be 2, it could be 3, 4, 5, or 6. Those are the outcomes, right? Okay, so for a football match, it could be a win or lose or a draw. So you just think about them. So like I said, playing soccer, it could be a win, a draw, or a lose. So just think about possible events or possible experiments and see whether you can come out with the outcomes. Okay, now measuring or estimating probabilities. Well, we can actually estimate the probabilities or the chances of some stuff occurring. Now, the basic or the foremost, the one that we all possibly can know of is when we have the case of, we know the frequencies over that particular event occurring and over the total frequency, right? So, like I try to put here, which says that the number of times an event would occur, right? The frequency with which an event would occur or has occurred in the experiment, divided by the total number of experiments conducted, right? So if I toss the head, I toss the coin 50 times, and then out of that, the head appeared 5 times. Now, so the number of times the head appeared, divided by the total number of times I conducted the experiment, will give us the estimation of the likelihood of a head occurring when I probably will do another experiment. Thing. Okay, so I have an example here, and then we assume that, for instance, let's take we kind of studied the Ghanaian economy over a period of say 50 years, and then we use set dimensions as excellent, good, okay, and bad. So 5 times in the 50 years, the Ghanaian economy was excellent. Now, 25 times it was good. Then let's say 10 times it was okay, and then 10 times it was bad, right? Now, over this time, if I want to find the probability that the Ghanaian economy would be excellent, it is 0.1. How did I get that? It is just that 5 times, which is the frequency, the number of times the economy was excellent over the 50-year study period, divided by the number of years we did this. So 50 over 5 over 50 gave us this. So this becomes the probability of the economy of Ghana being what? Excellent. And so you can do for the subsequent periods the probability that Ghana, the economy would be okay or bad, or just follow suit the same approach. Okay. So, and also just a little recap of the rules of probability. We know the addition rule, where we say if you're supposed to find the probability of, let's say, an event occurring, or, so for instance, if I toss a die, a fair die, and there are 6 possible outcomes, what is the probability that either 2 or 1 would occur or would show up, right? So that's, say, probability of 2 plus the probability of 1 would give me the probability of 2 or 1 occurring. Okay, now how about the multiplication rule? That's when we also want to look at the case of 2 events combined, right? So what is the probability that 2 and, so I want to find the probability of 2 and 3 out of the outcome set. So let's say I have an outcome of, say, 1 to 6. The probability that 2 and 3 would occur would be the probability of 2 times the probability of 3. Now it goes on and on. And then the complement rule, basically we know that the probabilities all add up to 1, right? And so the complement of a probability is 1 minus its probability, right? So if the probability that, let's say, 2 would occur is 0.4, then the probability, its complement probability will be 0.6 because 1 minus 0.4 would be 0.6. Now, I think these are basic concepts in probabilities. We will just have to take some time and look through. And then conditional probabilities, this is where you want to find the probability of an event occurring given that a certain event has occurred before, right? So you want to find the, like I was giving the example before, what would be the probability that it will rain given that the clouds have gathered? Or we can also turn it the other way around. And we can, just like if you cast your mind back to the idea of the Bayes theorem, it has some similar application of these conditional probabilities here. Okay, but well, I would advise you just take some time, go through the manual, and we have specific examples and then applications of this in the manual, which will be very helpful. Our point of interest today is what we call probability distributions, which we'll start using. We'll start with the idea of random variables. Now we say a random variable is usually any variable that could take any form, right, over some outcome set, right? And so, for instance, if I have, let's say, if I toss a die, it is possible that it could be 1, it could be 2, it could be 3, it could be 4, it could be 5, it could be 6. All these possible outcomes are what we call random variables. Any of them could occur. And so a random variable, normally which we mathematically represent as x, is a variable that possibly has possible values and could take any form, right? Now, considering random variables, they could be discrete or what's it called? Continuous, right? A discrete random variable here, we say, may take only countable number of distinct values, right? Such as this. Now, so when we say distinct countable numbers, they are more like let's say integers, right? Real values, nothing like decimals or fractions, right? So discrete random variables are always countable numbers, distinct values. The other side of it, which is the continuous random variables, could also take any form, including distinct variables or distinct values, and then what's it called? Non-integers as well, which is kind of say they could also be decimals, they could also be real values. And so you can have a value as say 1, you could also have 1.1, 1.5, 2 in that order. Right? So it's more like the continuous is a combination of the two, both decimals or fractions and then the real or whole numbers. But for the discrete, it is just only distinct values. Now for probability distributions, now the reason why we are more interested in this dimension here is, well, like I said, a lot of decisions are made by businesses where they are not privy to total information, right? For instance, you want to invest in the Ghanaian economy. You cannot tell whether the Ghanaian economy next year would be excellent, would be good, would be okay, or would be bad. They are all left to chance. Well, but given certain information, there is a likelihood that it could be this, it could be that, it could be the other one, right? So we kind of want to understand the possibility of an event occurring given a certain likelihood with which the event would occur, right? Okay, so we'll understand this further. We say the probability distribution of a random variable describes the chances of the occurrence of the possible outcomes of a random variable, right? It describes the chances. Okay, so what would be the probability that, well, after the elections, the market is going to boom, there's going to be so much money in the system, or after the election, inflation is going to reduce, or inflation is going to increase. You do not know, and so you would want to kind of do that kind of basic assessment before you do that. Now, supposing that all outcomes have equal likelihood of occurring, then you're just going to give them the same likelihood. Now, for instance, take the case of tossing a die. There are 6 possible outcomes, and so each of them has a 1/6 chance of occurring. See, that is the case of when we have equal likelihood, right? So, okay, but there are other cases where they may not all have equal likelihood of occurring. Now take this table. Now we have a fictitious table kind of trying to portray let's say, electricity generation for next year, projecting. Now, supposing that we have, let's say, these communities or regions X1, X2, X3, X4, and X5. So here, we are kind of projecting the demand for those periods so that we can plan ahead of the coming year. And so supposing this, we project that period 1 could have demand of 1,800, X2 would be 2,200, X3 would be 2,500, X4 2,800, and X5 3,000. These are the potential demands. Now, but you do know that for here, given this thing, this is more like a projection. But we are saying this is a random variable. Trust me. The fact that we are kind of projecting that this community would demand, let's say, 1,800 megawatts of power doesn't mean that it's going to be exactly so. It could happen. A lot of things, they could demand more, they could demand less of this value. It could be the same for this, it could be the same for that. And so here, how can we determine the likelihood of we getting this estimation sure? Now, the respective probabilities here tell the likelihood or the degree to which it is possible these projections could hold. Now, 0.2 for X1, 0.1 for X2, 0.35, and 0.3, 0.05. Now, what this is saying is that here we have a 0.2 chance that the demand for next year for community X could be 1,800. Now, the complement for this is 0.8, meaning that here we have a 0.8 chance that demand here will not be 1,800. It means that demand could exceed 1,800 or demand could be less than 1,800. And if it's less, it could be any value from 0 to this one, and it could also be any value from this value to infinity. And so that's what but these distributions, the probabilities attached to these projections is what we are referring to as the probability distribution. And so the possible outcome with their respective probabilities of occurring or respective likelihood of occurring. Now let's evaluate this data. Here, the one that has the highest probability or the highest chance of occurring is our projection in X3. It has 0.35. It means that here we have a 35% chance that our projection or expected demand for next year for community X3 is going to be right? But we have a 0.65 chance that we could be wrong. And it follows suit. But do notice that when we sum all of these probabilities, they must add up to 1. And indeed, all these probabilities here will sum up to 1. Take some time, sum them up, and you see. And so that is one basic, it's a rule actually in probabilities that all probabilities sum up to 1. That is how come we can easily find the complement of a certain probability. Okay, so I kind of just represented this same information on the graph here. These are the respective, the y-axis shows a graph of the graduation of, let's say, the probabilities, the possible probabilities. And then here, the demand for this thing. So each demand against the respective probability. Okay. So I hope you get the concept. So we are going to kind of apply this idea to help us estimate, right, the demand, or kind of make estimations, or kind of, so that, well, it's not going to be a perfect kind of estimation, but it is somehow, let's say, the closest you can get to perfection, given this idea, okay, knowing the probabilities of likelihood. Now, in going through this approach, we would first need to know the mean or the expectation of the random variable, right? Now, cast your mind back to what I just said. Now, from something like the expected demand, we are saying that it could be any value above or below whatever we have projected. And so when we put all these together, we kind of would have the mean, and then we'll kind of go ahead and do some basic statistics here. Now, we're saying that given a random variable where x equals x1, x2, up to x5, with their respective probabilities, we can find the mean or the average, or let's say the expectation or the average projection or the average demand or the average of that set of random variables by summing each random variable multiplied by its respective probability. So here we're saying that our E of x, or x bar, will be equal to the sum of all our random variables where I goes from 1 to n, pi times xi, where pi is the probability of random variable I, right? And then the random, this is xi is our random variable I. And so here is pi times xi. So for instance, let's go back to our random variables x1, x2. We say that x1 multiplied by its probability p1 plus p2 multiplied by the random variable x2, then p3 times x3 to whatever number of random variables we have available. Okay, so let's go back to the little table I showed you here. So these are our random variables: 1800, 2200, 2500, 2800, and 3000. So here, if I want to find the average of this, now the reason why, okay, so let me just, what we do here is to say, you take this value, this is the random variable x1, this is its probability p1, right? So this probability times this value, plus this probability times this value, and plus this times this, plus this times that, and we put it together, right? Now, the reason you do notice that these probabilities vary, right? The probability of this occurring is 0.2, this is 0.1, this is 0.535. They all do not have equal chances of occurring. And so we are trying to take into account the varying chances of occurring, and then by the random variable, right? So normally, I do know that normally if we want to find the average of a set of numbers, what we do is we sum them up and then we divide by the total number, right? So in our case, for instance, we had 5 random variables. We'll sum those random variables and divide by 5. But in this case, that is the case when we assume that they all have equal chances of occurring. Here, it is not the same. So we rather multiply the likelihood or the probability of that random variable occurring. You multiply the two, and then you sum it, you do it for all of them. So this is what we did here, and I had 2, 4, 4, 5 as the mean, right? The mean for, so the mean demand expectation, or the mean demand for next year from our table. Okay, now we would want to, the next thing to do after finding the mean is to find the deviation. How far or near are our, what's it called, the random variables from the mean? That could determine the likelihood of we hitting it right or we getting it very wrong. So what we do is to find what we call the standard deviation. Now, from basic statistics, if we are to find our standard deviation, we need to find first our variance, and then we'll take the square root of the variance to find the standard deviation, right? Okay, so we'll understand why we need to take the square root of it. Now, to find the variance, what we do is, the expression says that you take the probability pi into bracket your mean minus your random variable, you square it, and you do it for all the other things. Or let's say take your mean, find the difference between the mean and then the random variable, square that difference, and then multiply it by the respective probability of that random variable. Okay, so here you see we says where n goes from 1 to n, or I goes from 1 to n. So we have pi into bracket x bar minus x xi, or close the bracket, you square it. So the xi here, the pi would be the respective probability of this xi, right? And then the mean is going to be the same. Do not worry whether you make it x bar minus x or x minus bar. Now the difference here is we are going to square this difference, and so definitely it will be a positive value. So do not worry too much whether it is x bar or x bar minus xi or either ways. But preferably by convention. Well, we are not inventing the formula. It was done before we came, and so it doesn't hurt using it as it was propounded or it was made. Okay. So here, because we have this summation sign and we have a set of random variables, you do your x bar minus, let's say, x1, square this difference, multiply by p1, plus x bar minus x2, square the difference, multiplied by p2, and you do it till you get to what? Xn, or the last number in the set. Okay, so when you do this, whatever value you get becomes what? Your variance. And so we take the square root. Now what we have done here, you see, in squaring the difference here, now the standard deviation actually measures the variance or the variation or the deviation from the mean. How far or near is our random variable from the mean? So it's like you are trying to measure the distance. So it's like we have our mean, the mean is in the center, it's like the center value, and then the random variables are kind of scattered all around it. Now what is the distance between our mean and then the various random variables, right? Now what we did here, we squared the distances, right? It means like we have kind of overestimated, or we've doubled the distance between the mean and then the random variable. And so when we take the square root of it, we kind of normalize it, or we standardize it, we bring it back to the normal or the original distance, right? And so here, once you found your variance, take the square root of the variance, and then the variance gives us this expression. The square root of the variance will give us the standard deviation. Let's apply it to the information that we had before. Okay, so what we do here, the next thing is, so I take my 2445, which is the mean, x1, this is the first random variable. So 2445 minus 1800, whatever that difference is, I square it and I multiply it by the probability of 1800 occurring. I do the same, 2445 minus 1200, which is for the x2. I square that distance and I multiply it by 0.1, which is the probability of 1200 occurring, and I do the same for all. Now I get the value, and what I have is I think it's 292,475. Now when I have this value, I take excuse me. Okay, so yeah, so I do this and I take the square root of that value, and then what I have gives me my standard deviation. Okay, and so my so this is just a little mix up. This is rather supposed to be the answer. This value here is what is supposed to be under the square root sign, and this will be the final answer. Just a little mix up, forgive me there. Okay, so here, this is my standard deviation. Now, this is a little rule. If you have a big standard deviation, it means that your random variables are very far from your, this is more like a crude explanation of this concept. It means your random variables are really far from your mean. And especially if your standard deviation is greater than the mean, it means that, whoa, that is a big issue, right? It means you've really deviated from the mean. If it is smaller, well, it means they are relatively closer and closer to the mean. And so we would probably prefer a smaller standard deviation compared to a bigger standard deviation, right? So if you compare the value, so in our case, we have our mean to be 2445, and then we have a standard deviation of 5,400. Now, what this, in other words, would say is, now, supposing we are saying that the average demand is 2445, it means that what a standard deviation of 5,400.30 means is that, well, it is possible that our demand could exceed 2445 or could be less than 2445. But by how much? By somewhere around 540.30, right? So our mean of 244, supposing it goes beyond our 2445, then it will go up to about 540.80. Or if it is less than 2445, then it's going to be something, let's say, 2445 less 540.80. So that's what the standard deviation tells us. It gives you that average distance, right? Or deviation from the mean. Okay, one last concept that we would want to also understand here is what we call the coefficient of variation. This coefficient of variation is a measure of risk. It helps us identify the risk element involved in the decision we are making, right? How risky is the decision we are making? Okay, now the simple expression here is our coefficient of variation is computed by dividing the standard deviation over the mean. So our standard deviation divided by the mean gives us the coefficient of variation, the measure of risk. How risky? It kind of gives, it quantifies or gives a percentage degree of risk in whatever decision you're making. So how risky is this decision with regards to it not working or it working? Okay. Now, for the coefficient of variation, with regards to risk, we would all prefer to be risk averse as possible, although there are people who are very risky. The lesser the risk, the better, right? So if you have two coefficients of variation, or you're comparing the coefficient of variation of two elements, you would prefer choosing the one with the lesser risk element. Okay, so let's take this basic example here from the table and see how we would go about it. Okay, so I have the Ghanaian economy, which could possibly be excellent, good, okay, or bad. Now, these are the possible returns. So if the economy is excellent, you could have 25% returns. If it's good, 15%. It is 10% when it's okay, and it will be minus 10% if it is bad. Okay, now it says that the economy of Ghana could be excellent, good, okay, or bad next year with respect to probabilities of 0.2, 0.5, 0.2, and 0.1 respectively. Okay, so you just match up these probabilities to or with the respective rates of return. Okay, so kind of interesting issue here. Okay, so and now it says the economy of United States next year could also be these, and these are the respective probabilities right here. Now it says that find the expected returns of 100,000 investment in both Ghana's economy and the United States economy. Now quantify the risk associated with the investment. Now, which country is more economically viable to invest? Now, you see, think about it. Now, you are an investor. You have 100,000 cedis to invest. Now, you do want to evaluate two economies, the Ghanaian economy and then the U.S. economy. Find out which of these would be most viable. Viable in the sense that if I invest my 100,000, which of these economy am I potentially going to get the highest returns? But you do know that there are certain issues that we can say you have total control about. That is the outcome, what the economy could be. The economy could be very good and everything as in excellent, everything will work out for you. And for every 100,000 you would invest, you're destined to make about 25% interest. If it's good, you make 15. If it's okay, you make 10. But if it's bad, you're definitely going to make losses of minus 10. So now let's go through this process. Well, from my solution, I'll go through the case of one economy for you. And I'll urge you to do the other one, but just go through it. Okay, so now you would need to find your random variables first. So think about it. The first portion says that we should find the expected returns of 100,000. So if I am investing 100,000, if the economy is excellent, I would make 25%. So what is 25% of 100,000? That is 25,000. So the first random variable here is 25,000. So think about it. Do not use the percentages. Well, you can use it with the probabilities, but it could be a little something. So I would urge you to just go according to this procedure. Well, I know some of us are mathematically very sound, and so you can also come out with some other approaches. There's no problem. But just go with this one for now. And then so if the economy is good, you could make 15%. And so 15% of 100,000 is 15,000. And it follows you till the last one where we can have minus 10,000. And so here, to find the expected returns, what we can do here is say, you know that to find the expected return, which in other words is the same as finding the mean, what we do here is you multiply your probability by the random variable. Now, and then you sum them. So here, how many random variables are we going to get? We're going to get 1, 2, 3, 4 for excellent, good, okay, and bad. So here we know the probabilities for the Ghanaian case. Now, so let's try and do it here. Now, if the economy is good, it's excellent in Ghana, we make 25,000. We'll multiply it by the respective probability of 0.2. Plus, if the economy is good, we'll earn 15,000 on our 100,000 investment, multiply by 0.5. If our economy is okay, we are going to make 10,000, we multiply it by our probability of 0.2. And if our economy is bad, we are going to make minus 10,000, that is minus 10% of 100,000. And we multiply it by the probability of 0.1. So when we put all this together, what we have is 13,500, right? So this becomes our expected value, right? Okay, so given this one, 13,500, our expected value, so more like the expected revenue you could get if you consider the case of all the economies. Okay, so how about we find the variance? Now the variance says, or the expression here is, find the difference between the mean or the expected revenue, the expected value, and then the random variable. Square the difference and multiply by the respective probability. And so here, our mean is 13,500. The first random variable, that is when the economy is excellent, is 25,000. So 13,500 minus 25,000, whatever the difference is, I square it and multiply by 0.2. Then I move to the next one, plus, now 13,500 minus 15,000, I square that difference, I multiply by 0.5. Then I do for this one. Look at the last one. Interesting. Now this is 13,500 minus. Now the value here is again minus, right? So negative, negative, we would get positive. So here, whatever this turns out to be, you square it, and then you multiply by 0.1. When we put all this together, we have this value, quite a huge one. Well, normally the variance is always huge. Well, it is because we kind of have overestimated the value. Okay, so we have this value. Let me see if I can try and mention it. Would it be 1, 2, 3? So more like 82 million or 82 billion. 250 million, and it comes down in that order. Okay, so here we've been able to find our variance, so we can easily find our standard deviation, and then the standard deviation is the square root of our variance. So if I take the square root of this 82 is it what 8525000000, the square root of it will be 9,233.05. Okay, so this gives me my standard deviation. The first portion of the question, actually, the second portion, sorry, says that we should it says quantify the risk associated with the investment. Okay, so in quantifying the risk, in other words, that is like saying what is the coefficient of variation, right? So here it is our standard deviation divided by our mean. So our standard deviation 9233.09 divided by 13500 would be 0.68. So here, what this is saying is this projection we have made, the expected or the mean revenue of 13,500 and this deviation here is saying that, well, we have a 68% chance of it falling apart, right? Or of we missing it. Now the complement of this is 0.42. Now think 0.32. Okay, now think about it before we move on to the next part. If it is just one project and you want to evaluate whether the project is very risky or not risky, any coefficient of variation value, which is from 0.5 and below, is okay. If it is above 0.5, well, that is quite risky, right? So, or the closer it is to 1, the higher the risk. The lesser it is, or the closer to it to 0, the lower the risk. That's just kind of the basic way we interpret it. Because a higher percentage value, this is the same as like 68%. Well, that is quite risky. Well, but because here we are comparing it to another economy, you would have to do the same things that we did for the Ghanaian economy. Find the expected value for the US economy, find the variance, find the standard deviation, and also find the coefficient of variation here, like we've done here, and then compare them. In the Ghanaian economy, the risk involved is 0.68, which is, in other words, is 68%. In the US economy is 0.66, which is what, 66%. Now, which of these economies would you prefer investing? Well, they are both risky, 68 and 66. But comparing the two, or given these two instances, the US economy seems less riskier, at least by 2 percentage points. And so your decision, based on the coefficient of variation approach, would be to select the US economy because it has a lesser risk of investment, a lesser risk involved in investment compared to the Ghanaian economy. Okay. So I hope this session was fruitful and you understood the concept. Just take a little time, practice it. Don't get worried if you're not really getting it. Follow the procedure we have just shown, or I have just shown in the video. Consult your textbook as well, and you'll be just fine. Thank you. I'll see you in the next session. Bye-bye.